Okay, coming back to 2017 paper two. This was from the Department of Education, of course. So right here you are given a trig expression, right? So you're required to simplify. Simplify the expression in a single trigonometric ratio. So already you have sine a minus 360. So if you have 360 and above, I'm looking at angles like 540, 720, those angles above 360. What you do, you add to eliminate the 360. So we're gonna add 360 here, 160 degrees. So we're going to have sine A. Then looking at the reduction, we have a reduction here. So from the formulas or the reduction formula, you have sine 90 degrees minus A. This changes to cos A. And then if you have sine 90 degrees plus A, this also changes to cos A. Now, if we have cos 90 degrees minus A, this is going to be the same as sine A. So I want you to pay attention to the last one. The last one, if I have cos 90 degrees plus A, then I'm going to have a negative sine A. Negative sine A. So be very careful with the reduction. The cofunctions. You have 90 plus A, it's going to be a negative sine A. So everything else on the cofunctions is positive. So when I change the cos A plus 90 degrees, it's going to give me negative sine A all over cos 90 degrees minus A. Cos 90 degrees minus A. It's the same as sine A. Then tan, if it's a negative for all these functions, these are negative angles. If I have tan negative A, it's the same as negative tan A. If I have sine of a negative angle, it's going to be equal to negative sine A. If I have negative cos negative A, I'm going to have positive cos A. So for cosine is positive, right? And then the rest of these are negative. So getting to changing tan, it's going to be negative tan A. So on the elimination, sine A eliminates sine A. Then I have this negative canceling out this negative. So I have sine A all over. I'm changing tangent. It's equal to sine A all over cos A. Right? So the sine eliminates the sine eliminates the sine. So your answer is going to be cos A. That's the single reduction formula. So if you're confused of this step here, for instance, this one here, right? So let's get back to fractions. If I had A all over B, this thing is the same as A divided by A over B, which is the same as A over 1 times B over A, right? Which is equal to, because of this A cancels this A, you'll be remaining with B over 1, which is B. So that's what happened here. Now, getting to the next question. These are diagram questions. So in the diagram P, you're given 3 and T, that's your point P. on the Cartesian plane, and then you have OP being equal to the root of 34. Then you have HOP being beta, and beta is a reflex angle. On the diagram, before I answer the questions, I'm going to look at my diagram. I have R already. R is equal to root of 34. So key thing to understand that you need to know R squared is equal to X squared plus Y squared, right? This is Pythagoras. So when you're given this type of a question, always have these variables. Have R, we know R. Where is our R? X. We are given X. Okay, here is X. Right, so here I'm going to have I'm going to have 3, right? And then I have T this side, which is Y. I have X, which is 3, but I don't have T. So they're saying, without using a calculator, determine the value of T. This is what we need to do. So you're going to say T is the other side, right? T can only use Pythagoras because there's a 90 degrees here. Every time you have a questions like this, you're gonna sketch a perpendicular height. So I have T squared plus the other side is 3 squared is equal to the hypotenuse side, which is the root of 34 all squared. This is Pythagoras theorem. I'm using Pythagoras because there's the 90 degree there. There's a right angle. So therefore, T is going to be equal to 5. So when I solve this thing, I'm gonna get T being equal to 5. If you're still confused, I'll break it down for you quickly. You have T squared plus 9 being equal to 34, right? So this 2 cancels this root. So you have T squared being equal to 34 minus 9, which gives you 25 T squared. So square root plus or minus, right? Plus or minus. So T is going to be equal to negative or positive 5. So what's going to tell me the sign? It's going to be here on the Cartesian plane. I have Y here. Here are negative values. Then here it's positive values. For the X, positive values here, then negative values here. So T being below the x-axis, it's going to be equal to a negative 5. So therefore, T is equal to negative 5. That's what happened there. So my answer is negative 5. Now I have the next question. In the next question, just gonna do this. Let's put it here so it's easier to work with. Good. So I know that T is equal to 5. Good. So tan B. So 5.2.2 tan beta. It's going to be the opposite side over the hypotenuse. So it's going to be equal to negative 5 all over 3. Then we have 5.2.3 cos 2 beta. Good. Now, we cannot substitute 2 beta because we only have beta. We only have beta. Here it's only beta here, not 2 beta. So the best thing to do is to use the reduction formula to use the identity because this has an identity. So going back to its identities, you have just gonna make space. Just gonna look for something. Let's look at cos 2 beta. Right, this is equal to 2 cos squared beta minus 1. It's also equal to cos squared beta minus sine squared beta. Please be careful of this thing. Be careful because of here we have again cos squared beta my plus sine squared beta, which is equal to 1, right? The plus equal to 1. So when you substitute, please pay careful attention to the minus there. And then you have again 1 minus 2 sine squared beta. These are all the identities for the double angle. Then going back to our equation, I can say this is equal to 2 cos squared beta minus 1. Then 2 cos beta, when I look at cos beta, it's going to be equal to x over r, right? So remember, cos is equal to x over r. And tan is equal to y over x. Sine is equal to y over r. These are just simple revision. So the value of x is 3. The value of r is the root of 34 all squared minus 1. So I have this is going to be 9 over 34. So you have so I'm going to say 2 times 3 all over the root of 34 all squared minus 1. My answer is a negative 8 over 17. That's my answer for that question.